So, hi everyone, welcome back to the session. I hope you all are doing good and let's begin the class. So, yesterday we discussed about some routing protocols and we learned how RIP works. RIP, first of all, stands for Routing Information Protocol. Now, after RIP, we are going to learn about another routing protocol, which is EIGRP. So let's quickly learn what's the full form of EIGRP. EIGRP stands for Enhanced Interior Gateway Routing Protocol. So this is what EIGRP stands for. Now, before moving further, I want you guys to understand something. We learned that EIGRP is also known as Advanced Distance Vector. So the reason behind this name is Advanced Distance Vector Protocol is it means that it selects the best route based on the distance as well as based on the link. So what I'm trying to say here is, as we learned yesterday, that RIP selects the best route based on the distance. So if there is a topology like this, so RIP will always choose this route because there's only one hop. It doesn't matter if the speed was 1 Gbps on these links. And let's say 10 Mbps here. So if we think about this logically, this route will be much faster than this. But when RIP is configured in some network, then it chooses the best route based on the distance. Now, when we talk about EIGRP, EIGRP works with both distance and link. So it will check distance as well as link, or you can say it will check the speed between the links also. So that's the reason we call it as Advanced Distance Vector. So now let's quickly understand some other characteristics of EIGRP. And let me take a look to chat. So if you guys are facing some difficulty in RIP, we can do a short practical quickly, and after that we can look into EIGRP. Let me know that if you want me to do some more practicals of RIP, or shall we move ahead with EIGRP? Sure, we can do a small topology quickly to understand the configurations, and I would like recommend you to write the configuration this time so that you can refer to that whenever you are trying to like perform the practical. So let me open the packet tracer. So make sure you make a note of the commands which I am writing down. Sure, I'm repeating a practical for RIP. Let's understand that quickly, and after that we can move forward with the EIGRP. Make sure you make a note of commands this time so you don't have to like look for a reference on the internet. So we'll quickly add some routers and switches. We have a router here and one here. Then we have one switch here like this. Then add some end devices. Now let's connect them together using the cable. So I will just go with the process, and in case if you find something difficult, you can write in the chat. I will repeat that part. So let's configure a network on router number 1 of 192.168.1.0. Then we have for router 2 2.0. Let's configure 192.168. Between these routers. So what we are going to do here is we will assign 3.1 to router number 1 and we will assign 3.2 to router number 2. And similarly, we will assign a network of 1.0 on these pieces and 2.0 on these pieces. So let's go to router number 1. We'll go to CLI. So we just have to say no, enter, enable, configuration mode. Then after that you can change the name using host name and the name for the router. So we will configure the IP address on interface FA0/0. You have to type IP address and after that you can add the IP you want to configure with the default subnet mask. Once you have configured the IP address, make sure you make the port up by adding command no shutdown. You have to run no shutdown to make the port up. Now we will configure interface FA0/1. Now let's go to router number 2 and configure the IP addresses. Down and interface FA01 will have IP. Okay. Interface FA01 will have the IP 192.168.3.2. Add the subnet mask and we can run no shutdown now. Now we are done with the configuration of IP addresses. Now we can move ahead with configuring DHCP, or you can just configure IP address statically, like manually on the PCs. So we are configuring DHCP pool here. Network is going to be 192.168.1.0. Port router will be 192.168.1.1. We are done with the configuration of DHCP. Let's quickly check if PCs are getting the IP address. Yes, DHCP is working. Now we are done with the basic configuration and we will move ahead to configure the routing protocol, which is RIP. So we have the IP address on all the devices. Okay, so we will move to router number 1 and you have to go to the configuration mode. After this, you have to type router RIP to enable the routing protocol. Once you have done this, you just have to type version 2. After this, you have to type network and inform the router about directly connected networks. So we have 1.0 directly connected to us and 3.0 as a directly connected route. That's all. So this was the configuration of RIP. After this, you can take an exit. Similarly, go to router number 2. And in case you are not sure what are the directly connected routes, you can go to either you can go to the enable mode, or you can just simply type do show IP route in the configuration mode. So in order to run show commands in configuration mode, you have to type do before them. And once you press enter, so these are the directly connected networks on router number 2. So we have 2.0, we have 3.0. Now we can move ahead towards configuring RIP. So we'll type router RIP, then version 2 network 192.168.0, then again network 192.168.3.0. That was all. We can take an exit from here also. And now if we try to ping from this PC to this PC, so it will be successful. So the first few packets might get dropped because of the R protocol, but after that you will see the ping will work. So let's try this from command prompt. We are getting a reply. Now if you try doing the transmission through this, so it will work. It says successful, successful. Similarly, if we try pinging from PC1 to PC3, okay, it says successful. So that's how RIP works, and using these protocols you can make devices from different networks communicate with each other. Is it clear to you guys now? Great. I hope, Jaspal, you are now like able to identify your mistake and you can perform the practical now. So this was all about RIP. Now let's understand some characteristics of EIGRP. We were discussing EIGRP, and when it comes to EIGRP, we can also call it as advanced distance So first of all, EIGRP was introduced by Cisco and used to work on Cisco devices only until 2013. So it became an open standard protocol After 2013, it became open standard, and now it can be used on any vendor devices. Then after this, we have this is a classless protocol. Which means it supports CIDR and VLSM. So the subnetting and the VLSM, which we learned a few days back, it supports both of the network distribution types. So the maximum hops which can be connected in EIGRP are 255. However, the default limit is 100. So after the 100th of hop, if you want to make communication possible, you have to make the configuration for that. Okay, so then after this we have AD value. AD value which we discussed during the RIP, AD value of EIGRP is 90. So if a network is configured with both RIP and EIGRP, tell me which protocol will be preferred. Now you can take a screenshot of this or can take a note of this. I'm just removing the written characteristics. Yes, I'll just write the AD values of all protocols for you, and let's check that. So, as I said yesterday, lower the AD value, higher the preference. So is it clear to you guys? Now I'm writing the AD values for. So first of all, we have directly connected routes. So the AD is 0. So if there is a route which is directly connected to a router, so and after that you can reach the destination, let's say this router, through through multiple routers over any protocol, be it RIP, let's say EIGRP, or be it OSPF. So in such cases, the directly connected route will be most preferred. So the AD value of directly connected routes are 0. Then after that we have static route. So the routes which you add manually, the AD value is 1. Then we have RIP, the AD value is 90. I'm sorry, the AD value is 120. So the AD value of RIP is 120. Then after that, if we talk about EIGRP, the AD value is 90. And for OSPF, the AD value is 110. So these are the values. You can keep a note of them. And okay. So why we say that EIGRP is distance vector and link state as well. We will talk about that, Dilkhush. Once we will once we discuss about the metric which is used by EIGRP, we'll learn why it is said that it uses both distance and link. Okay. Yes, for BGP it is 20. So I hope this is clear now, and let's understand more about EIGRP. Okay. Now the sixth characteristics of EIGRP is it uses multicast address of 224.0.0.10 to forward updates. Let me quickly know in the chat that what is the multicast address for RIP. We discussed that yesterday. Perfect. So yes, the multicast address for RIP is 224.0.0.9, and for EIGRP it is 0.10. So in EIGRP, hello packets are sent every 5 seconds and hold time is 15 seconds. Then after this, it supports equal and unequal load balancing. Also, it works on dual. It uses dual. So dual stands for diffusing update algorithm. So we will learn about this equal and unequal load balancing and dual. We'll learn about them in detail. Uh, Before that, I want you guys to like take a note of these characteristics so that we can move ahead. So there is something related to internal and external routes, Shubham, and we will only be discussing about internal routes. So the internal AD value of EIGRP is 90. However, if we talk about the external one, so it's something I guess 170. So that's not something related to CCNA. And as of now, you can just keep in mind that AD value of EIGRP is 90. Okay, let me rewrite this. This is diffusing. Yes, BGP is also not a part of CCNA. We will not be discussing about BGP as of now. Let's just focus on this and okay. So the dual stands for diffusing update algorithm. Now there are some packet types which are shared between routers when they are connected over EIGRP. So let's say these two routers are connected and there are some like we can say there are some requirements which needs to be fulfilled before this neighborship can be made between routers. Now let's first understand what are the parameters which are required between routers to be a neighbor to make the neighborship between them possible. So the very first requirement or you can say the parameter is router should be in same subnet. After that, we have something known as autonomous system number, and so they must have same autonomous system number. So now when you create a network between routers, let's say this using EIGRP, so you assign a random number which can be from let me just check the range. So this number can be from, so it must range between 1 to 65,536. Now, when you assign this number to this, let's say this network, to configure all the routers with the same number. Let's say you selected 10, and once you configure EIGRP on this router, so you have to configure it as EIGRP 10. And similarly, when you will be configuring on router 2, you have to keep 10 with your configuration. So you have to keep them in the same autonomous system so that they can communicate with each other. So two devices with different autonomous system number cannot communicate with each other. So they have to be in the same system. Autonomous system number is a number which you assign to EIGRP. And yes, now the range goes from is extended even after 65,536. So that's something, that's a number which you assign to this EIGRP protocol, and the routers or the devices which you are configuring this protocol on should be in the same autonomous system. So you'll be able to understand this more once we do the practical. So you have to keep them in the same autonomous system. And in order to do that, you have to use the same number on devices. So let's say you connected one more router here, but you configured it with another EIGRP, let's say 5. So this router would not be, it won't be possible to make communication between them now. So they have to be in the same autonomous system. Since it's a part of EIGRP 5, it cannot communicate with these routers. Is it clear now? They have to be in the same autonomous system, and for that you select the number and configure all the devices with that number only. After this we have, they should have same k values. So we will be discussing what these k values are, and we will look into that also. Now, once all of these parameters or requirements are met, after that, two routers can communicate, and they maintain some tables, which are, the very first table we have is neighbor table. Then we have topology table, and the last one is routing table. So now let's understand what are the content of these tables. I hope till now everything is clear to you guys. Organization of their own. Yes, so AS numbers are used in these routing protocols to make communication. No, that's not something assigned by INA. This can be done internally for like these can be used for internal communications as well. Once you are configuring devices, you can assign number of your choice. So you will be able to understand this more once we are on the practical, once we are using the packet tracer. So you guys will be able to understand this if you are like confused about autonomous system number. So don't worry about that. Let me know if till now characteristics are clear to you and what are the requirements which are there to make neighborship possible. We will learn about k values. There are 5 different values. So we will learn about that. So let's move ahead and learn what are the content of these tables. So first of all, we have the neighbor table. Once these routers are connected, they share let's say the first router send the hello packet, hello message, and to which the router 2 replied. After this, once they discover each other using the hello packet, after this they will share updates. Like router 1 will inform router 2 that these are all my routes, and similarly router 2 will share the routes connected to it. Now, when we have the neighbor table, the routes received from these routers are installed in this table. So we have all the routes which are there connected through our neighbors in our neighbor table. And let's say this router is connected through 3 routes to the destination router. let's say this is R2, R3 and R4. And now let's assume that from R2 to R5 there are again multiple routes. So there is routes like these. So now R2 will share its best route, and that route will be installed in topology table. So once we receive the route from R2 to reach R5, we will see which is the best route out of them, and we will install that in the topology table. Now to reach R5, we have best possible routes from R2, R3 and R4. Now out of these received routes, the best among best will be installed to the routing table, and that will be basically used to make the communication. Is it clear to you guys? What are the contents of these tables which are maintained by EIGRP? So we have basically three tables which EIGRP maintains, and the very first table we have is neighbor table. So in neighbor table, all the routes which are there on which are like whatever routes R2 will share with R1 here, that these are my all routes. These are the routes which I am taking care of. So these routes are installed in this table, neighbor table. Then after that, out of these routes, let's say R2 is connected to R5 through multiple ways. So these are like the multiple possible ways to reach R5. So out of these all routes, the best out of them will be installed to the topology table. Now, in order to reach R5 from R1, we have the best route through R2. Is it clear now? We have the best route through R3 and R4. Now we will compare the best routes received from R2, R3, R4, and best of these, like whichever will be the best of these will be installed to the routing table. So let's say R3 ends up to be the best out of the best routes which we have received from these routers. So the route through R3 will be installed to the routing table. Okay, so is it clear to you guys all? Is it clear to you all? So these are the content of these tables, and these three tables are maintained by EIGRP. So I'm repeating myself. Neighbor table, the table, like the updates are installed in this table once the parameters match. So we talked about three parameters, and after that, whatever updates are received from the routers, so those updates are installed in neighbor table. After that, in topology table, routes received after the connection is built, after this, whatever the routes are there from neighbors to reach the destination are installed in topology table. So here we have, if we create a neat diagram and take just two routers. So let's say we have to reach R4. Now R2 might have multiple routes to reach R4, and R3 might have multiple routes to reach R5. So out of those multiple routes, the best ones will be installed to topology table, and the best among best will be installed to the routing table. So let's say these two were routes to reach R4, and the best one was this one. So we will install this route in the topology table, and now if we compare the route between R2 and R3, let's say the best one was R3. So ultimately, the route via R3 will be installed to the routing table. I hope this makes sense now. Okay, so now let's take a small break of 10 minutes, and after that we will learn what are the configurations to configure EIGRP in a network. Okay, so hi everyone, I'm back, and let's take a look at chat. Okay, so there's some discussion going on, and okay, so there's a, maybe a doubt from Shubham. So Shubham, the AS number I guess you are talking about is related to BGP, and for EIGRP we only assign the autonomous system number. Okay, not confirmed. So INA assigns in the case of BGP, that's not for EIGRP. Okay. Okay, we have another question related to authentication. So the fourth, we can say the fourth parameter is an optional one, and so no. So if you are configuring the password on one router and not on the other, so the neighborship won't come up. And Shubham and Ashok, uh, there's some discussion between you guys also. I hope you are able to sort it out. Let me know if you still have any doubt. And for others who are not able to understand this, this is something related to advanced courses which are CCNP and not related to CCNA. So, Shubham, I guess that's an explanation by Ashok, and no, it's not like that. You can ask any question in the group, but during the session, there are some people who are fresher and are very new to this. So this might make them confused. So now let's move ahead and understand how the EIGRP configuration works. Okay, great. Thank you. So now we will understand what are the commands which are required to configure a EIGRP protocol on a network. So we will take some routers and switches. Now let's connect them together. Okay. Let me. So we have these networks for our devices, and we are going to learn about EIGRP now. So first of all, let's quickly complete the basic configurations, which are configuring the IP address and DHCP pool. So we'll go no, enable terminal, and after that go to interface FA00 and assign it the IP address 192.168.10.1. Add the subnet mask, no shutdown. FA01 IP address 192.168.40.1. Take an exit and the DHCP pool, add network, the default router. Then we have router 2 with us. We'll go to interface FA01, IP address 192.168.40.2. We are configuring IP here and no shutdown. Then we will go to interface FA00 and assign it the IP address 192.168.20.1. Mask and no shutdown. Similarly, for Ethernet 1/0, take an exit and configure the DHCP pool. Network 192.168.0. That was all about router number 2. Let's move to router number 3. You know, enable conft and interface FA01. Okay, so we have successfully configured the IP addresses and DHCP pool on all of the routers. Now assign the IP to PCs. And here we go. Now we will move ahead and we'll see how we can configure EIGRP on these routers. So let me get notepad as well so that you guys can take reference to that after class. Okay. So we will first of all check what are the directly connected routes. And if we look in the table, we have 10 and 40 directly connected on router number 1. Now, in order to configure EIGRP, you first have to run the command router EIGRP, and after that you have to write the AS number. So let's take 10, press enter, then we can say network 192.168.10.0, then again network 92.168 40.0. Now we will move to router number 2. We have 3 directly connected routes to us: 20.0, 40.0 and 50.0. We'll type router EIGRP, then again you have to use the same autonomous system number, which is 10. Then after that add the networks. So if you see, there's some neighborship notification, and it says that there's a new agency which is up now for fast Ethernet 01. So now we will add the last route, which is 192.168.50.0. Okay, now similarly on router number 3, it to show IP route. Once we are ready with our directly connected route, we are good to configure EIGRP. Router EIGRP10, network 192.168.30.0, then again network 192.168.50.0. Now if we check the router number 1 and check the routing table of this router, we have 10, we have 20, 30, 40 and 50. So we now have all the routes which are there on the network. And similarly, if you go to other routers and look into the routing table of the particular router, you will see all the routes will be there. So also you can see a D near to some routes. Now D represents EIGRP. So that was all. This was the configuration of EIGRP. Pretty simple, right? Now let's take note of these on a notepad, and after that you guys can take time to try this out. So first step is your IP. You can configure configure the IP address on PCs directly using the static method, or you can just simply configure DHCP. In step 3, configuration looks like something this: router EIGRP, then you have to type the autonomous number. After that, we'll add the directly connected routes. We used 10.0, we used routes for router number 1, and similarly for router number 2, ones will look like the router EIGRP10, network 192.168.20.0, So this was all about EIGRP. We will take 20 minutes to do the practical, and let me know once you are done. So guys, class is not yet finished, and this was the time for like performing the practical. So I am back, and we have some. Okay, so there were few questions. So Jaspal said, what if we don't assign any numbers? Okay, so Jaspal, if you try configuring EIGRP without autonomous system, that won't work. So that's an incomplete command. You will get some errors. So even if you try, so let's take one router, and so let's see what error we get. And if we go like router EIGRP, so yeah, so see you get a error which says incomplete command. So you have to like add the autonomous number, and EIGRP will work only after that only. Okay. So I hope you guys are done with the practicals. And how RIP? Okay, so Shubham, yes, RIP works on application layer, but I'm not pretty sure about the logical reasoning behind that. I might have to look into that. We'll let you know on the Telegram. Don't worry. Okay, okay, done, done, done. Okay, so where's the file? Just a minute, guys. I'm locating a file. Okay. So I hope you guys were like able to make the communication between these networks possible. And this was, I would say, uh, still we have some more details to discuss about EIGRP, which are like the metric which EIGRP use. So yesterday we discussed about the metric of RIP, which was hop count. But when it comes to EIGRP, there are some different metrics, and we'll be like discussing about that in the next class. Okay, we have some. Can we connect? No, we cannot connect devices from different autonomous numbers, different autonomous systems, and yes, we will discuss about all k values which are from k1 to k5, but in the next class. So we'll be discussing about dual, which was diffusion update algorithm, and we'll be discussing about k values as well. Yes, you will get recordings after the course is completed, which is around 15th of October. So yeah, what is the range of? The range is from 1 to 65,536 for autonomous system members. So we can discuss about recordings after the class. Let me just wrap this up. I have some meetings aligned and have to leave early today. So this was about EIGRP. We learned how this works, and we learned about the configurations as well. So there is yet some topics which have to be covered in EIGRP, which are like dual, how like what is dual algorithm, and we will be discussing about k values also. We will understand how metric of EIGRP works. So metric, if you guys remember, we discussed about when we discussed about RIP, we discussed that metric for rep is hop count. Similarly, we have some metrics for EIGRP as well. So we'll be discussing about them in the next class, which is tomorrow. Oh, which is on Monday, I guess. Yes. So let's meet on Monday, same time. So on Monday, we will try to do one more practical for EIGRP, and after that, we will cover the remaining topics. Then we are good to go with EIGRP, and that will wind it up. So that was all for today. Thank you for your time. Bye, guys.